And today I'm here to talk to you about a function that you may wonder the reason for, especially its form and most likely, and even how it turns up. I'm talking about the equation for circles. And now you see the equation for circles may go like this: a minus x minus a squared plus x minus y minus b squared, equals r squared. And this may come confusing because what you might all be used to ever since before this, of course, I'm going to keep the R capital to Dismas. Before this, of course, what you may have seen would be something like y equals mx plus c, or something more complex like y equals ax squared plus bx plus c. Alright? And then you get the equation for a circle. And the second thing about the equation for a circle is the fact that it shows up like a circle. And this may not seem weird to you at first, but if you take any other equation, like a quadratic equation, notice how you only have one line at one point on the x-axis, of course. Now, if you take a quadratic equation, let's take a very simple one, x squared. Now, what you see is at one point on given x, there's only one y coordinate. But for the circle equation, you have two. And now I can help you with this. Now, the first thing we can do is go back to a more simpler version. X squared plus y squared equals r squared. Equals r squared. We'll keep it capital R so that doesn't do us anything else. And now this is called an implicit function, and I would like you to write that down. Implicit function. And that's called implicit because the y isn't directly defined, unlike y equals mx plus c. Now, functions like y equals mx plus c are called explicit functions. Explicit functions. So that is basically what that would be called. And now to see why there are two sides on the y-axis, so two y's instead of one, what we can do is make y the subject, and now that would transform into y. You can turn it into y squared equals r squared minus x squared. And what you can do then is square root it, and that would equal y equals the square root of the entire thing, of course. Technical difficulties. There you go. So, you may wonder why on earth it only gets 1 instead of 2, and even Desmos is only showing 1 y for each x. Well, the thing is, here's a little example. What is the square root of 4? And you may say 2, just like Desmos. But there's another square root of 4, and that is minus 2. So the correct way of saying the square root of 4 would actually be plus or minus 2. And that's basically what happens. Because if you notice in this one, if you rearrange it back to normal, so that would be this one, then what happens is you get two values. So y equals plus or minus the square root, and that is how you get that. So I'll do it here, and here you can say y equals plus or minus the square root, and that can allow for two values. And as I'll go back to the function over there, if you take r squared minus x squared, then that means that y is equal to the square root of the radius squared minus x squared, which looks very similar to Pythagoras, which you might note as well. Now, this is why when you look at here and you zoom in, and you take 1x, like let's take this one, at the point at half, exactly half, what you could get is 0.866, but on the other side you get negative 0.866. Now it gets a bit more, it looks a bit differently, a bit different in comparison when you look at the one over here, and that's because of something else which we'll learn very soon. So now you've got understood that, and if you've understood why there are two y's for each x, and if you look at it the other way, two x's for each y. Now let's move on to the first equation, which should be used more often, since in this one you can freely change the radius. The radius as well, but the center mainly. See? And now what this basically done is, you might have learned graph transformations. Now let's take away graph transformations that relate to the y. So not like this. No, I'm talking about inside. So basically what happens here is, if f of x equals x squared, then what happens here is f of x minus 2 becomes x minus 2 squared. And we don't need to, and let's not expand that for now, but you could if you wanted. But as you can see, the turning point and even the solution seems to have moved to forward instead of to backwards. So if we put something like x plus a, then it would be the opposite, and so in order to make it exactly what you want, forward, backward, in any way what you can do, I change my wording, is you can make it x minus a. And so if you want to move it, let's say 10 forward, what you could do is make a equal to 10, and there you go. So something similar, and that's basically the same thing that happens for y. Now if it looked more like this, x minus a squared, I'll show you in a bit. If we show x minus a squared and leave y alone and add b outside, it will be a different story. In this case, if you move b, and I'm actually not sure why they didn't do that instead, but somehow if you do b, then the add of b will be, then positive b is all you need, you don't need any negatives. So if you want to add by 10, and let's make 0 easier, so it's a 0, to make it easier, then it goes by 10, and the center is now at 0, 10. 0 for x, 10 for y. But so that would have worked if it were the case, but somehow it's not the case, and that may actually be a bit peculiar and unnecessary, but I might research into that. So instead what we do is x minus y minus b, and now for the same thing, if we did y plus b, it would be the opposite. So if we wanted to go forward 4 times for y plus b, we would actually have to put minus 4 into b. See? So instead have minus b. And that's basically what you need to know. And smash that like button, please. Like and subscribe. Click the notification bell for more nice content like this. And have a good day.